today's lesson we'll be covering pages 280 and 282. You want to have your graphing calculator. Lesson 6 of Unit 10, Volume, Word Problems. We'll be looking at the volume of a rectangular solid, and recall, volume of a rectangular solid is length times width times height. Using the diagram below, write a function v of x to model the volume of the box where x is measured in inches. So we have the dimensions here, x minus 1, 2x, and x minus 4. Length times width times height. V of x is equal to x minus 1 times 2x times x minus 4. And the order in which these are written does not matter. Each represented dimension of the box must be greater than 0. Otherwise, we wouldn't, if the length is 0, that's not possible. For each represented dimension, write an inequality, then solve for x. So for the length, x minus 1, we write the inequality x minus 1 must be greater than 0. We add 1 to both sides, x is greater than 1. For the width 2x, that must be greater than 0. Divide by 2, x is greater than 0. And for the height of x minus 4, that must be greater than 0. Add 4 to both sides, x is greater than 4. So x must be greater than 1, 0, and greater than 4. So we take the largest of these. So x must be greater than 4. The volume of the open box is 40 cubic inches. Determine algebraically the dimensions of the box. Verify your answer using a graph. Alright, so we'll take our v of x and replace it with 40. So 40 equals, and I'm just going to write the 2x first, followed by x minus 1 times x minus 4. Let's expand the right-hand side. So, in other words, perform the operation of multiplication, multiplying the two binomials here. X minus 1 times x minus 4. I get x squared minus 4x, and minus 1x is minus 5x. And negative 1 times negative 4 is a positive 4. Distribute the distribute the 2x. 2x cubed minus 10x squared plus 8x. Let's put it in standard form. Subtract 40 from both sides. 0 equals 2x cubed minus 10x squared plus 8x minus 40. Now we factor. There's 4 terms. We'll factor by grouping, but before that there is a GCF of 2 that can come out. Now grouping, splitting the first 2 terms. GCF there is x squared, x minus 5 in parentheses. The last 2, 4 is common. 0 equals 2 times x minus 5 times x squared plus 4. So we have it in factored form. Now we set each factor equal to 0. 2 equals 0. That's not a true statement. X minus 5 equals 0. X squared plus 4 equals 0. Add 5, x equals 5, subtract 4, and take the square root of each side, and x equals plus or minus 2i. We reject the plus or minus 2i. We're trying to find the number of inches, so we want only real values. X equals 5. We want to find the dimensions of the box. 5 is not a dimension, it is the value of x. So So if we go back up to our box, right, the length was x minus 1. So 5 minus 1, which is 4. The width 2x, 2 times 5, which is 10. And the height was x minus 4, plugging in 5 for 5 for x, 5 minus 4 is 1. So there are our dimensions, 4, 10, and 11, and 1. And if we do multiply them, the result is 40. Now graphically, checking it graphically, I'll take the right-hand side of our equation and put it in for y1. And please make sure you're doing the same at home. And the left-hand side in for y2. And let's see, we know our volume is at 40, so we'll change the window, adjust the window. We also know our x value is 5. So I think for the x, I can leave that. I'll put it at 0. I'll leave the max of, I'll put it 6. And the y min, 0. The max, we know it's going to get as high as 40. I always like to see just a little more. I'm putting it at 50. Now press graph. And for our sketch, here's 40. And this was 6, so this is about 4. So what we have here looks something like this. Let's back up at 4. And the point of intersection, second trace, number 5. Enter, 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 is 540. Exercise number 2, rectangular box has a height of x feet. Its width is 3 more than its height. And so I see this here, so its width is 3 more than its height. So that would be x plus 3. And its length is 1 less than twice its height. So twice its height less 1, minus 1 is the length. If the volume of the box is 90 cubic feet, use a graph to find the dimensions of the box. Write an inequality which gives all possible values of x. Okay, so it's up to you whether or not you want to draw an actual box and label things. Height is x, the width is x plus 3, and 2x minus 1. For our inequality, we'll take each of our dimensions and write the inequality greater than 0 and solve for x. So 2x minus 1 has to be greater than 0. I add 1. Divide by 2. X is greater than a half. X plus 3 must be greater than 0. So we subtract 3, and x is greater than negative 3. And x must be greater than 0. So we want the largest of all of these, which would be a half. So x must be greater than 1/2. Write an equation for the volume y in terms of x. Okay, so y, our volume, is going to equal length times width times height. And again, the order does not matter, so I'm going to go with x first, times x plus 3 times 2x minus 1. This we place into y1. And in y2, 90. We know our volume is going to go up to 90, so let's adjust the window. I'm going to put it up to 100 for the y max. And I think I'm going to leave x as is right now. Okay, there we have it. It looks like 390, so an x value of 3. Just check it first with the table or by finding the point of intersection. Yep, 390. Quick sketch. Again, we want to find the dimensions. So our x value is 3, that is the height. And this is feet. 3 plus 3 is 6. And 2 times 3 is 6 minus 1 is 5. And if we multiply this, 30 times 3 is 90. Next, page 282. We have a piece of cardboard 12 inches by 10 inches is to be used to make a small open box. Squares of equal size are cut out of each corner, then the sides are folded to make the box. So in other words, and this is what we did in class, I showed you in class the other day. Suppose we have a, I've got this 12 by 13 or 12 by 10 sheet of paper, and I cut off squares of equal sides on each corner. Take out a square of x on each corner. In case you missed class the other day. The squares are supposed to be of equal. Oops. Now remember, my original dimensions were 12 across by 10. Okay, but now we've taken out a length of x from each end. So from here to here now, instead of being what I was originally 12, is now 12 minus 2x. And from here to here, originally we had 10, but we took off an x at each end, so now we have 10 minus 2x. And we fold this up and we have our little box, or little open box. And you can see, once I get it folded up, okay, what's the height of our box? The height of our box is x. Right? The height of our box is x, and what was originally 12 is now the dimension 12 minus 2x, and what was originally 10 is now 10 minus 2x. Quick demonstration there. Okay, so here's our original cardboard, 12 by 10, and then we're cutting out squares of x. From each of the four corners, and now drawing the box, the open box. My height is x, our height is x. The length is now 12 minus 2x, and the width 10 minus 2x. Write a function to model the volume of the box. Define the variable first. Well, x is our height. The volume is going to be the height, x, times the length. Change that. F of x is going to equal x times 12 minus 2x times 10 minus 2x. Length, height times length times width. Write an inequality which gives all possible values of x. Okay, so this is where we got to go back and take each dimension and write the inequality that that dimension has to be greater than 0. 12 minus 2x must be greater than 0. Actually, I'll put this down here. 12 minus 2x must be greater than 0. I subtract 12, negative 2x is greater than negative 12. When we divide by a negative 2, that switches the inequality symbol, so x is less than positive 6. 10 minus 2x must be greater than 0. Subtract 10. Divide by negative 2, we switch the inequality symbol. X is less than 5. And x must be greater than 0. So for the two less thans, we take the smaller, and we have the inequality that x must be greater, the compound inequality, x must be greater than 0, but less than 5. Right? If we were to put a 7 here, we'd have 12 minus 14, which is negative 2. We cannot have negative measurement, and we cannot have measurement that's equal to 0. Use a graph to find the dimensions of the box to the nearest tenth of an inch. That will maximize the volume. That will maximize the volume. So we're going to use the calculator to calculate the maximum. In Y1, we place our expression of the volume x times 12 minus 2x times 10 minus 2x. Not too sure about the window, but let's see. I'm going to, well, our x's have to go from 0 to 5. That I know. That we know. I'm not so sure about the y. Right now I have it at 100. I'm going to leave it there. Okay, and that's actually enough. If I did not see the top of this curve, right, let's say if my y was at 50, if I did not see the top of that curve, then I would have to increase my y max. So let me put that back to 100. And again, sometimes I like to see a little more than what the actual domain is. Oh, didn't help anyway. All right. I would focus on getting that point first before I sketch the graph. Let's get the max. Second, trace, and let me write this down. Find the max on the calculator. For our x min we had 0. For our x max we had 5, and that was from this. This told us what our domain was. Now back to finding the maximum, it's number 4. To find the max, it's second, trace, number 4. It asks for a left bound. Your cursor needs to be to the left of your turning point up there, your relative max up there. So to the left, holding it down, left-hand arrow. It's to the left of the top of the hill. Now it asks for a right bound. That cursor needs to be moved to the right of the top of the hill. For the guess, you don't have to do anything, just press enter. So we have the point 1.8 107429, 96.770576. Okay. So if that's 5, about 1, 2, 3, 4. A little off there, but that's okay. So this is close to 2, and this was 100. Make it about here. And I'll try drawing, sketching this. Use the graph to find the dimensions to the nearest tenth of an inch. Okay, so 1.8 is x. 1.8 inches is the height. 12 minus 2 times 1.8. 8.4. And 10 minus that should be 6.4. So here are our dimensions. Once again, I thank you for your attention.